Okay, so let's have this one. So finding the coordinates of the latera recta of an ellipse. So these are the formulas to get or to find the coordinates of the latera recta of an ellipse. So if the ellipse is in horizontal form, these are the formula. And if an ellipse is in vertical, so these are the formula. Now, on this given equation of an ellipse, take note that in an ellipse, A is always greater than B. So the bigger denominator is the A squared. And this formula to solve for the A squared, that's B squared plus C squared. Now since 9 is greater than 5, so therefore this 9 is the A squared. And this 5 is the B squared. So therefore our formula, that's y squared over the a squared. So since a squared is the denominator of y squared, so this ellipse is in vertical form. Now, from this equation, solve for a. So we have this a squared equals 9 squared. Then to solve for a, take the square root. So a is equal to 3. Then b squared equals 5. And take the square root. So b is equal to square root of 5. Then to solve for c using this formula, so transpose b squared, that becomes negative. So a squared minus b squared is equal to c squared, or take the square root. So c now is equal to square root of a squared minus the b squared. Then substitute the values. So we have this a squared equals 9 and b squared equals 5. Then 9 minus 5, that's 4. Then the square root of 4. So c now is equal to 2. Then for the center of an ellipse, that's h and k. So from this given and to this formula, so we have this h, that's positive 2. And k, since this one is positive, so therefore k is negative 3. So h is positive 2, k is negative 3. Now, since the ellipse is in vertical form, so these are the formulas we're going to use to solve for the latera recta. So from this given, now take note that we can combine these two formulas, the plus c and the minus c. So this is now the formula, the plus and minus c. Then substitute now the values. So h is 2 minus b squared, the square root of 5 squared over a, that's 3. Then k is negative 3, then plus and minus c. Then we can rewrite this one, the plus 2 and the minus 2, the plus 2 and the minus 2. Then simplify. Now this 5 over 3 is in decimal form, that's 1.67. So this 2 minus 1.67, that's 0.33. And this negative 3 plus 2, that's negative 1. Then this 1.67, that's 0.33, and negative 3 and negative 2, that's negative 5. So these are the coordinates of this latera recta. Then the other two coordinates, so combine these two formulas, the plus c and the minus c. Then substitute now the values. So h is 2 plus b squared, square root of 5 squared over a, that's 3. Then k is negative 3, then plus and minus 2. Then rewrite this one, the plus 2 and the minus 2. So the plus 2 and the minus 2. Then this 5 over 3, that's 1.67. This 5 over 3, that's 1.67. So 2 plus 1.67, that's 3.67. And negative 3 plus 2, that's negative 1. Then 2 plus 1.67, that's 3.67. Then negative 3 and negative 2, that's negative 5. So these are the coordinates of the last latera recta. Now, to solve for the length of this latus rectum, this one, so using this formula, 2b squared over a squared, Then substitute now the values. So 2b squared, that's the square root of 5 over a is 3. Then this square root of 5 squared, cancel, that's equal to 5. Then this 2 times 5, that's 10. So therefore, the length of this latus rectum in decimal, that's 3.33.